Imagine that you've just finished your data analysis project. You've spent hours and days doing complex analysis and carefully crafting data visualizations. Your output now looks something like this. You have done original work, but unfortunately, your document has no personality. It looks like any other Quarto document. Hi, my name is Umair Durrani. I am a data scientist at Prasad Group, and today I'll show you how to quickly theme your docs and apps and your ggplots using large language models. When you think about theming your documents and outputs, you think about styles, colors, and fonts, and you may get started with company branding guidelines. But what if there are no guidelines available, or the project that you are working on is a personal project? In that case, you need to think about what makes more sense in the context of what you're doing. For instance, you may be analyzing iris flowers dataset, and you may want to start with colors of the iris flowers. Quarto provides different options for theming your HTML outputs and Reveal.js outputs. Essentially, in this example project, we want something like this. Website output that contains the colors from that flower image, and ggplot visualizations that use similar color themes. Similarly, the Reveal.js presentation should contain similar color theme as well. For doing that, you need to know CSS or SCSS. And now we are getting outside the territory of data science and more in graphic design. Here's an example SCSS for HTML and Reveal.js outputs. You need to import the font that you want from Google Fonts or any other provider. You also need to provide some SCSS defaults like background colors. You need to provide the font family and headings font family for your website document, but also separately provide the presentation heading font and heading color for Reveal.js output. Similarly, you need to separately provide the heading information for website as well as for Reveal.js. So there is a lot of repetition. And your output would look something like this. You still need to customize your ggplot scales and colors. BrandYAML makes part of this process easy. You provide just a single BrandYAML file that will change the theme of all your Quarto outputs. You can provide name and other information in the meta section of BrandYAML. You can provide detailed information about the number of and the types of your logo images. You can also provide a complete color palette where the color names can be provided and customized by you. And you can either use hex colors for the semantic colors, or you can just use the names that you provided in the color palette. Similarly, you can provide custom fonts that may be available on your machine or that may be sourced from Google or Bunny fonts, and then use them for base fonts, heading fonts, and fonts for your code blocks. However, this is still in the territory of manual branding. If branding guidelines are available, you need to read through all of them and then extract style information and manually create your BrandYAML files. You also need to then think about ggplot2 themes and scales that are more appropriate given the palette in the BrandYAML. This is hours of tedious work, lots of trial and error, and does require some design expertise and knowledge of HTML and CSS. Let me introduce you to the Brand This R package, which has the sole goal of enabling you to create BrandYAML files and ggplot2 color palettes as quickly as possible using large language models. It uses Google Gemini as the default LLM API, but you can use any other LLM API supported by the Elmer package. It gets you started in minutes rather than spending hours thinking about colors and styles. Here's an app that is provided with the Brand This package. This is called as Create Branding, and the Create Branding app is built on top of the BrandYAML app in the BSLib package. It has a section on inputs and outputs, a section on the documentation that also shows you the code blocks and what they look like. It has this editable BrandYAML section with a default BrandYAML, but the main feature of this app is that you can chat with an LLM API, give it images, and provide some information about yourself to generate personal or company BrandYAML files. In this case, I just generated a BrandYAML file by giving an image, and it immediately updated the theme of this app. Within the plot section, we can also generate plots and color palettes, which are based on the BrandYAML color palette. So Create Branding app can get you started very quickly. Let's talk about generating a BrandYAML file using BrandThis. With Create Brand, you can provide information about yourself, like your name, any inspiring image, tell it that it is a personal brand, and then provide it with your favorite LLM API. If it is a company brand that you want to generate, you can provide it with multiple images and information about your company. The Create Brand behind the scenes uses the tool calling feature from Elmer package. For example, if a user wants to know what is the current weather, it would send a message to the chatbot and say, what's the weather right now at Fenway Park? And it also provides with an R function called as getWeather. The assistant does not have the ability to run the getCurrentWeather function itself. That function will be run on user's machine after the chatbot makes that request. Then the function runs, gets an answer, and then that answer is provided to the chatbot. Chatbot interprets that answer and then provides the answer to the user. Here's how I am using tool calling with the Create Brand function. I first generated the MakeChat function that creates the client brand using a system prompt. And then using the register tool function, I give it tools like get fonts combination and check the contrast of the foreground and the background colors. If an image is provided by the user, those image paths are generated. And then if it is a personal brand, I add a prefix that you need to create a personal brand YAML, use a function called create palette from images before providing the prompt to the chatbot, and then provide the final prompt in the chat function. If it is a company brand, the process is similar, but you can provide more than one images, and so we use do.call with prompt and Elmer images. Images can be provided from the file. For that, we use the content image file function from Elmer. Once the chatbot returns a BrandYAML output, it is converted to a BrandYAML object using the brands.yaml R package. The next function is about suggesting color scales that are already available in the ggplots and the Palettier R packages. To this end, I use the Ragnar R package. RAGNAR enables you to do Retrieval Augmented Generation, or RAG. It can store information in a database, for example, a DuckDB database that has chunks of information that you provide. It can retrieve relevant information when a question is asked to it, and then generate a relevant and accurate answer. Here's how the suggest color scales work. At the first step, I created a knowledge store using the RAGNAR R package. For the Palantir package, I provided it with the documentation pages that I want the LLM to learn from, then created a store location, and using the embedding JAMA model, created embeddings using local LLM for this database. And then using the RAGNAR store insert function, I provided chunks of information, for example, the palette names for continuous, dynamic, and discrete palettes, and then also inserted the documentation pages in this knowledge store. Now that the knowledge store is ready, the suggest color scales function can use it. You provide it with the previously generated brand YAML file, the package that you want to retrieve information about, the number of similar results that you want it to look for, and the LLM API. Then you provide the system prompt. These prompts are available in the package source. Provide it with the hex color codes from the brand YAML file. Create a chat object, and then register the RAG database as a tool. And now the chat object is ready to receive the semantic colors from the brand YAML file and generate an output about the most relevant scales. I used a brand YAML file for generating this slide deck as well. And what you are seeing right now is the result of generating scales for the palette from the Palantir R package and then using them in these three visualizations. You can see that it effectively uses color palettes that are more similar to the blue color that was specified in the brand YAML file for this slide deck. The final function that I want to discuss with you from the brand this package is for creating color palettes directly from the brand YAML file. And this uses the structured output feature of Elmer package. With brand's create color palette, you provide it with a brand YAML file, and instead of a raw unstructured output like you see here, the goal is to generate a structured output of an R list that contains multiple vectors of different types of scales and the color palettes for those scales. So here is the result of using those color palettes that were generated for the brand YAML for this slide deck. Again, you see that the blue colors used in these visualizations are very similar to the blue colors provided in the brand YAML file for this slide deck. So how does the create color palette works? You provide it with a brand YAML file, and the color information is extracted from it to provide the semantic colors directly to the chat object. You then create the chat object with a system prompt, and here is the meat of the create color palette function. It uses the structured output format for generating a structured list object. Here I specify the palette type object, which is specified inside a type object from Elmer. You give it information about what this object is about, for example, a collection of color palettes for ggplot2, and then For each of the color palettes that we want to generate, we tell it that this is an array type, which stands for an R vector, and then provide it with information about that type of palette. In this case, I'm saying first discrete palette, a list of color hex codes without names or comments. Similarly, there are other palettes in this output. I am doing it for 2 discrete palettes, 3 sequential palettes, and 2 diverging palettes. And finally, within chat structured, instead of the chat function, we provide it with the semantic colors from the brand YAML file, the type object that we want to generate, and that produces the output that contains the R list containing our color palettes. So in summary, why would you like to use the brandlist package? It is fast. It produces relatively polished color palettes and scales and brand YAML files that would probably be sufficient for your use case. It is consistent because that brand file that it generates can be used in your Shiny apps as well as Quarter documents and R Markdown documents. It is smart because it has the knowledge about the color scales and themes and also semantic colors. And we are done. Thank you. And to connect with me, you can find me on GitHub, Blue Sky, and please check out the brandlist package on GitHub. Thank you.